When I was younger, I liked to run mini experiments at home. One of my favorites was to see what sunlight could do to an insect when passed through a magnifying glass.
He carried that interest through into high school and then into university, where he graduated with a PhD in microbiology.
For me, science has always been about leaving the world a better place. If one day people say there was once this guy called Shaquille, I think I would have succeeded. After graduating, I continued working at the university, sometimes repeating trials hundreds and thousands of times, just to be able to find tiny specks of information. I thought there must be a better way, so I took a leap and started my own business.
Shaquille's company is working to eliminate fish fraud, a $2 billion problem, and has developed a machine that will instantly identify the correct species of fish.
The product that we are making is currently under development phase. The individual parts of the machine work, but now we're automating it into one lab in a box.
Fish fraud causes $23 billion in damage to the seafood industry every year and affects every single point of the seafood supply chain, just like this wet market here behind me. According to Oceana, 20% of global seafood products are affected by fish fraud. In Hong Kong, where we are based, the problem is severe, with the WWF finding that 9 out of 11 seafood products tested in local supermarkets were affected by fish fraud. Put simply, fish fraud is the act of mislabeling fish products. This is done to sell low-quality fish as high-quality fish, or to sneak endangered and controlled fish species past the prying eyes of regulators and customs. This still exists as a problem today, mainly because there are thousands of different fish species that we eat, and it is impossible to identify them based on morphology alone. There needs to be a technology-based solution to identify this fish for fish fraud to go away.
The first step is for the raw fish sample to be lysed using a lysis solution. The cellulose dipstick is then lowered into the tube, which binds with the DNA. The DNA-bound cellulose dipstick is then lowered into a tube containing ethanol, helping to remove molecular weight contaminants such as salts and detergents. The DNA-bound cellulose dipstick is washed in water to release the bound DNA. Water containing released DNA is then mixed and incubated with a solution to bind a protein to the DNA that will help guide DNA molecules for sequencing. The DNA mixture is then loaded onto the sequencer, which will then start producing usable data within 5 minutes. Here, we show the inner compact electronics of the prototype. You get a glance at the inner working of the heating block, which is used to heat the raw fish samples in the cell lysis step. Tissue Program has helped us in the past to propel our concept into a product. We once again seek your funding for further R&D and to commercialize our product in the market at scale. Thank you for your consideration.